Aloha, Richard Halverson here. This is ICS211, and today I'm going to cover a merge sort. So let me share my screen. All right. So it's section 18.8, so I'll cover 18.8 and the following lab. And okay, so merge sort is a sorting algorithm kind of similar to quick sort, but we divide the list up into two halves, and then we recursively sort each half, and then we merge the sorted halves together. So the recursive part comes in where we continually divide the list into halves until we get down to two lists that have just a single element. And then the merging is what actually does the sorting. And by taking two sorted lists and merging two sorted lists into one sorted list is actually pretty easy. So here, this shows a demonstration here where we have a list which first computes it computes the middle and splits it into two lists, and then it's going to sort each one of them separately. So next it takes this smaller list, splits it into even two smaller lists, and splits this into two lists. And it does the same thing for both halves, all the way down to where we down at the bottom here, we just have two elements. And so the two elements are easily sorted into the single element lists are already sorted, obviously. And so the two lists are easily merged into a sorted list. These two lists are easily merged into a sorted list. These two lists are easily merged into a sorted list, and so on. And we end up at the top with a sorted list. So like, for example, this sorted list and this sorted list, we would first take this element, then take this element, then take this element, then this element, then this element, then this element, and that's how we fill these slots up here. It's hard to follow when someone else is trying to explain it to you. It's easiest, really, if you just go through this yourself and focus and try to understand what's going on. So these little exercises here can test your understanding of merge sort. So, for example, determine the index J and the left and right partitions. So J is the middle, it's the index, so it's going to be, this is going to be the index of J is going to be 0, 1, 2. It's going to be 2, I believe. Yes. And then the left part, when I is 0 and K is 4, when I is 0 and K is 4, the left partition is going to be 1, 2, and 3, I believe. Yes. And the right partition would be 4 and 5. In this case, I is 3 and K is 5. So I is 0, 1, 2, 3, and K is 5. So J, the middle, would be this one, which is 4. And the left partition would be 23, 8, I believe. And the right partition would be 35. So you can go through this, make sure you understand it. Here's another animation, and you can see how the numbers are are divided up and then merged back together again. So you can trace through this, make sure you understand how it works. This is the merge sort algorithm here. And we start out here by initializing a bunch of integers into an integer array. We print it out, we merge sort it, and then we print out the sorted values. Merge sort here takes an array of numbers. This is the index of the lowest number, and this is the index of the highest number. This is the merge sort program. It's recursive. First, we find the J. The J is the midpoint. It's the the highest index in the lower partition. So this merges the numbers from the beginning to the lower partition to the partition point to J, and then this merges the numbers from J plus 1 up to the highest number, the highest index number, and then once these, the lower half is sorted and the upper half is sorted, then the two halves are merged together using this merge method. And so here's the numbers array. This is the lowest element, this is the highest element, and this is the midpoint. And so it's merged together here, and this is the merge algorithm which we were looking at before, where we figure out the left position is I, the right position is J plus 1. So this is the left array, the lower half, which is one array that comes in sorted, and then this is the beginning of the right array sorted. So this goes from J plus 1 all the way up to K, and this goes from I all the way up to J. The left half is I up to J. And then this loops through looking at both sides. And if the left position number is smaller than the right position number, then the set of merged numbers gets the left position number. Otherwise, the left position number is going to be greater than or equal to the right position number, in which case the merged, where the merged array is being stored, gets the right position number. So it alternates back and forth depending on which one is smaller. It always takes the smaller. So when it pulls off one, when it pulls off the left position number, it increments the left position pointer. When it pulls off a right position number, it increments the right position pointer. And then when a number is stored in the merged array, the merged numbers array is what's storing the final merged result of merging the left and the right. So it goes all the way until one of them is hits the top. When either the left position pointer goes all the way up to J, or the right position pointer goes all the way up to K. If either one of those happens, then it's done with one side, and then depending on which side it's done with, it just copies over the rest of the numbers from the other side, the ones that are left, depending on which side it is. And then after it's all done, it's got this merged numbers. It's got the merged array with both of them in from both lists, and that gets copied back over into the numbers array. All right, so that's how the algorithm works. You might not have understood it when I was explaining to you, but just go through it yourself, concentrate, step through it in your mind, and make sure you understand how it works. It's pretty straightforward. All right, so these questions here have results that are similar to the quicksort section just above. Okay, so here's the lab. This is this merge sort lab. Now this is actually a really simple lab because they start out and they give you the program that does this. It reads in an array, 6 digits or 6 numbers here, this 6 element array, and then it outputs the unsorted array. And then what it does is it sorts it, and each time it outputs what the indexes are, the I, the J, the J plus 1, and the K. And then the J plus 1, and the K. That's printed out so you can see as it calls itself, the indexes, you know, get smaller and smaller, and it gradually sorts, and it splits it down to single element lists, and then it merges them back up again, and we end up with a sorted list. That and what this problem is asking us to do is to add a comparison counter. So we're going to add a counter to count the number of comparisons. Okay, so if we were just to run this right now with this data, copy, paste it here. So if we run it right now, it actually has it has this part, it has this part, and it has this part, and all we need to do is add this part. So let's take a look at this algorithm here. This is exactly the same algorithm as on the previous page, and here's the merge sort program, and we call merge. Merge sort is calling itself, and this is the method which merges the two sorted lists. There's the lower half of numbers is a sorted list, and the upper half of numbers is a sorted list, and this is the dividing point. Okay, this is the dividing point. And so this is the merge program, and this really is the only real comparison. It's here we're comparing the number in the left position with the number in the right position. And we're going to take the smaller one. We're going to take the smaller one and store them in this merged numbers array. This merged numbers array, this is an array which we initialize every time we enter in merge. We initialize this new merged numbers array. And what it does is it copies from the left list or the right list one at a time. It copies each time it copies the smaller one. So in the end, merged numbers has the sorted list, because each time it stepped through, it picked the smaller one of each side, pulled it off, stored it in. In this case, the left one is smaller than the right one, so it pulls off the left one, stores it into the merged list array, and increments the left pointer. And otherwise, it pulls off the right one, and then increments the right pointer. So this is really the only comparison that counts. Okay, this here just moves the rest of them over because the right list has been exhausted, so it copies over all the rest of the left ones. In this one, the left list has been exhausted and copies over all the rest of the right ones. Okay, each time we increment the merge pointer that points to the merged list, and when we're all done, the left list is empty, the right list is empty, and all of the elements are in the merged numbers list in order. Okay, so this is the only place that counts comparison right here, because this is the comparison, and then it's either going to do this or this, and then it's going to keep on doing that. Compares again. It's either going to do this or this, and until we're done. So I'm going to put the comparison counter right here. I'm gonna call it comparisons plus equals 1. That's where I'm gonna count. And I got to initialize this comparisons. I'm inside of a class here. I'm going to create a static variable, integer comparisons equals 0. Initialize it equals 0. I'm utilizing this hint right here. Use a static variable to count comparisons. The hint is you got to put this word static there. And then I guess we have to print it out. We have to print it out, print out the comparisons. We have to do this. And so to do this, we're going to do that at the end. Here, this prints out the new sorted list. That's this one. And then right after that, we can print out comparisons, system out, print line. Let's do the same thing, / comparisons, quote plus comparisons. All right. I think that might be all we need to do. Five, 8, 3, 2, 1, 5, 9, 8. 3, 2, 1, 5, 9, 8. The number is different. Let's see. Let's see. I put this in the wrong place, didn't I? This is actually where the comparison takes place. This one. This is the one I'm counting. This is the comparison. All right. Yes, because if I put it up here, then when this thing loops, I missed that one. I actually want to count this. All right, so let's see if what this does. All right. Well, anyway, this once you get this running, you're ready to do the lab, which is you're ready to do this lab here, this lab assignment number 3, where we take our merge sort program and combine it with the insertion sort and watch the growth in the number of comparisons as the size of the array increases. So anyway, I finished sections 18 point which ones were the 18.8 and 18.9, and so that completes chapter 18, and next time we'll start with chapter 19. Thanks for watching.